Hello. Hi. Here's my hand. Hello. I've created a miniature film studio here in a corner between parts of my kitchen to show you some small parts for my project, my current project. I am planning to create some tinder for lighting up with a flintstone. If it works, I will try this mushroom here. This is a mushroom growing on wood and typically used for making tinder, at least in Europe. I can't exactly say if, but after all, making tinder is not a great deal. It works with lots of organic materials, any sort of cotton wool or whatever. So what I want to do, I want to make a solution of potassium nitrate, a salt which is used for, what's written here, used as an ingredient for curing meats and give the characteristic pink color to bacon and hams. And well, it can also be used to soak some organic material in a solution, and then it's easier to burn with just a little spark from a flintstone. And that's what's actually needed to do. I'll try it with this paper here from the paper roll, like here from my kitchen paper. You can't really make this burn with just a little spark from the flintstone and steel. It might work if you use a modern magnesium steel. I don't know actually, I don't have one. I just have an old-fashioned flintstone system. But if you soak it in potassium nitrate solution and let it dry, you'll get a result which is easier to work with and burns exactly the way it needs to. It's much more flammable. That's, by the way, why buying potassium nitrate is apparently is restricted in most of the European Union by now. Which is not actually a problem. You can buy it in small quantities, and if you just want to do some tinder for making a fire using flintstone, the small quantities you can easily get are by far enough. All you need is 10 grams of potassium nitrate for 1 liter of water. Now I don't want to do a whole liter, because that's far too much for me. I use 1 deciliter, a tenth of a liter. Therefore I would need 1 gram of potassium nitrate. And I'm using this little beaker that came with my syrup against coughing. I got a nasty flu last weeks. And I use this small scale here, unfortunately. Yes, it does focus. I just have to hold the thing. I take a small spoon. It's not overly poisonous, the whole thing. I wouldn't eat it spoon by spoon, but let's give it a try. I'm looking through the monitor of the tablet I'm filming with. It's 0.91 grams now. How much is it now? 1.00. And all I'm doing now is actually putting this in this bowl, add my water. I'm using regular tap water, Swiss tap water, which is clean in terms of chemical stuff. We don't need chloride or fluorides in the water normally, but we have a lot of minerals from the mountains and the stones everywhere. But I think the people doing this exactly same technique in the Middle Ages did not have cleaner water than I have here. It does not need distilled water. So 1/10 of a liter and 1/10 of 10 grams. Stir it a little bit. It seems like it dissolves easily, and that's no problem at all. So all I do is I soak the thing in it. I don't use any gloves, as I said. I'm quite sure it shouldn't be a problem. Even more since I have seen a man doing this at a medieval market. He did not use anything to protect, so this seems to be perfectly harmless. At least as harmless as normal table salt, you know. But it will dry better if I do something about it. Here you go. This here. I do have some professional looking chemical equipment downstairs, but I just think after all it does not really matter. Now I let it sit and dry, and we will see if it works. Here we are back in my kitchen studio. We can try out now how it worked. Now we have two different pieces now, and I'm sure you will see right away which one was the one treated just by trying to burn it. You see, this is the kitchen paper. It burns until it lies flat, and then it's over. This one, you see it keeps glowing, and it's eating through the paper. There was no flame, but it keeps eating itself through, sort of. So when there is a spark coming to the paper on the left, it will be sufficient to make it all glow, and you have plenty of heat now. Plenty, it depends, too much to touch at least. But it will be sufficient heat to make some straw or grass or whatever you have, some next part, tinder sort of work. But you've seen the treated paper is clearly on the left, and it works like a charm. Grab my steel and my flintstone. You see, this is actually the steel. and a piece of flintstone. And by using this steel this way, putting the paper on the stone, then trying to strike it. It's kind of hard, there is not much space here. Ah, here. Ouch, yeah, and striking the table doesn't help. That all doesn't work out. Ah, you see, probably you can see it in the front. Yeah, here there was a little piece was stroken by one of the sparks, and it actually started. It seems like the result is more resistant to sparks than it was desirable in this case. But I'm quite sure if you had a magnesium steel or something modern, it would probably have done the trick. And it actually did the trick in one small part. But it did not burn as easy as the tinder I got together with this package. My brother got me some 2 years ago. So those people are professionals and you can see it. But I think the general system works, and it's probably a question of the material you actually take. There are some sorts of cloth. Too thick cloths are working bad, or at least worse. Thinner cloths are working better, so I expected this paper to work better. If you happen to be interested in geology, by the way, a piece of flintstone I used before, the small one came with the package. This bigger lump here of not the greatest quality is one I found in Switzerland. And in general, flintstone in Switzerland is not very common, so I'm still quite happy. And you can strike sparks with it quite well. So, I guess that's it. Thank you for watching, and see you next time.